Let us begin our session with an important question. What happens when fire meets electricity? What if the cables carrying dangerous current catch fire? Can anyone guess? It's easy, right? Obviously, it could lead to a disaster. So in this video, we are going to explore the design concepts of water spray fixed fire protection system that can prevent disaster in high risk areas like factories, power plants and substations. So let us imagine a particular scenario of a substation, and we already know that cables and cable trays will be installed in a substation, and the cables carry high voltage electrical energy and they are coated with highly combustible materials. So a short circuit in a substation triggers a fire in the cable trays. So the fire quickly spreads, risking catastrophic damage. That's why water spray systems will be designed in accordance with NFPA 15. And also, the main purpose of water spray system is not only to put out the fire, but to cool all the surfaces to stop the fire from restarting after the system is turned off. Since our topic is related to the water spray system design basics, we need to talk about the critical design considerations that we need to keep in mind when setting up a water spray system. So nozzle spacing and spray pattern. So regarding the nozzle spacing, we cannot just place the nozzles randomly. As per NFPA 15, the nozzle spacing should never exceed 3 meters or 10 feet to ensure every inch is covered with water spray. And related to the spray patterns, NFPA 15 states that all the protected areas should be covered. It means, I will just reframe my words, the nozzles shall be placed in such a way that the pattern should overlap each other. So the design must ensure that these nozzles meet or overlap. Otherwise, the complete area cannot be protected. And in some cases, as per NFPA 15, we can exceed the requirements above 3 meters distance. However, we need to check with the manufacturer about these particular details. And also, a single system shall not protect more than one fire area. And you can see the figure of a nozzle spray pattern here on your screen. This is the nozzle. This is the spray pattern. This one we call it as spray profile. And we have a fixed angle orientation, radial distance, axial distance. All these will be discussed in detail when we cover the topic of water spray nozzles. Next key design consideration is design density and minimum operating pressure. It's not as simple as spraying water everywhere in order to protect the equipment or cool the surface. Design density is one of the most important consideration in water spray system. So as per NFPA 15, the design density can range from 0.15 GPM per square feet to 0.5 GPM per square feet. For each and every equipment, there is a fixed design density. We will cover that in next slides. And coming back to the minimum operating pressure of any nozzle protecting outdoor hazards, please make a note of it, outdoor hazards shall be 20 psi as per NFPA 15. Now let us talk about extinguishment methods before we move further. This is the very heart of any water spray system. We need to understand how water spray system controls burning and what makes it effective. So coming back to the extinguishment method, if you look at your screen, we have surface cooling. So it means water spray systems do more than just drench a fire, they cool the surfaces. and smother flames by producing steam, break down flammable materials through emulsification, and dilute hazardous chemicals, all of which plays a vital role in slowing or stopping fires. It's not just about putting out the flame, but it's about controlling them from every angle. I hope you understand this particular concept. If you have any queries, you can just put in your comment section and let us discuss further. So let us understand the basic rules for protecting a particular cable tray. As we already discussed, cable trays requires the protection as well, especially in substations. So let us look point by point. If you look at this particular screen, we have mentioned like the design density rate shall be 0.15 GPM per square feet if we have the insulated wires and cables or non-metallic tubing. And we can consider the other design densities as well upon approval from authority having jurisdiction or local authority. If you want to bypass NFPA 15, you need to have the approval from AHJ, and automatic detection devices shall detect smoldering or slow to develop flames, because in cable trays, especially through the cables, there will be slow growing fires, wires short, or things are increasing very slowly. We cannot identify. So because of that, we need to provide automatic detection devices to catch the slow developed flames as well. So exposure protection concept shall be referred where it is likely that the flammable liquids or molten materials might spill and expose these cables, non-metallic tubing and tray supports. In that particular case, we need to consider the application rate as 0.30 GPM per square feet. So here I mentioned like for insulated wire and cable or non-metallic tubing in open trays. So these things we need to remember when we design the cable tray protection with water spray system. So in industrial projects, we have belt conveyors and drive units. So we need to protect all the hydraulic boilers as well. So we want to make sure when the fire system operates, we shut down the equipment. We want to stop moving the burning material. So in that case, we need to consider the application rate as 0.25 GPM per square feet for conveyor belts and drive units. And also please note, we need to protect the belt, means we need to protect from the top as well as from the bottom. So top and bottom should be protected by using the open spray nozzles, and these nozzles shall be placed to direct water spray onto the hydraulic oil, belt, contents on the belt or the drive unit to extinguish fire. And also if you look if you have worked on some projects, you will understand this material through the belt conveyors will go to some other buildings as well. That time if the fire occurs at this particular point or at this particular location, the burning material should not reach to the other building. That's the reason we need to protect that building as well. So during fire, we need to shut down the conveyor operation. So here it's mentioned like interlock the detection system with machinery to shut down conveyor operation. We have to make sure this. And also, please note, the water supply shall be capable of supplying both the design flow rate and host stream allowance 250 GPM for a minimum of 1 hour duration. So this is also a major point you need to remember when you are finalizing the demand for the water spray system. So we need to consider the design flow rate and we need to add 250 GPM to the design flow rate, then we will get the system demand. And in order to select the water tank shall be capable of, or the fire pump shall be capable of having water for 1 hour duration. So control of burning. If you have pumps, compressors and related equipment that handle flammable liquids or gases, we need to consider the design density as 0.50 GPM per square feet. And if you have liquid pool fires, flammable and combustible type, then the application rate will be 0.30 GPM per square feet. And the water spray system shall operate until all fuel is consumed or shut off the flow of leaking fuel or burning material can be otherwise extinguished. Exposure protection. Water spray system shall operate as intended for the anticipated duration of exposure fires. So basically exposure protection applicable for vessels. The application rate would be like 0.25 GPM per square feet as per NFPA 15. Nozzle spray patterns meet or must overlap. This is also a requirement for all the equipments as well while designing the water spray system. And there are few more considerations to be discussed. We will discuss those in detail when we consider a particular project of water spray system protected for the vessels, and this will be discussed in next classes. So structural steels also shall be protected with water spray system in some particular scenarios, like exposed beams to be protected, for example in aircraft hangars. And this is the extract from NFPA 15. It shows wetted surface of a structural member. So here we will place the nozzles. As per NFPA 15, so many people misunderstood that on one side if we protect it is enough, but actually if you look at FM guide, we will understand the other side of the beam also to be protected with the nozzles. This mistake should not happen in your particular project. However, please note, for horizontal members the application rate would be 0.1 GPM per square feet. For vertical members it should be 0.25 GPM per square feet, and all depends whether we require water spray system or not on project specification requirements. But in most cases aircraft hangars beams shall be protected, or exposed beams shall be protected with water spray system. So one more point to be discussed here: approved fire resistant insulation may substitute performance based engineering analysis, may substitute water spray system. So it means water spray system can be avoided if it is protected with approved fire resistant insulation. So here we are going to discuss about metal piping, tubing, conduits and racks. In power plants and in most of the industrial projects, if you are aware, we need to protect through water spray nozzles for these particular items as well. If you look at the screen, the design densities are also provided here. I will explain you in a while. Water spray nozzles shall be directed toward the underside of the pipes, tubes and conduits. So nozzles shall be positioned less or equal to 2.5 feet below bottom of rack. That one we will discuss when we explore more into the design part of this particular items. So for now just look this particular table. Here it is mentioned like number of rack levels 1 2 3 4 5 or 6. Here it is mentioned like the design density at the lowest level to 0.25 GPM per square feet, and it's reduced to 0.20 GPM per square feet if you have 6 number of racks or more. And the design density at the upper level shall be 0.15, 0.1. All this will be discussed in future classes. At this point of time, just remember metal piping, tubing, conduits and racks may require water spray fixed protection. So transformers shall also be protected with water spray system. So water spray system shall provide complete impingement on all exposed exterior surfaces. The application rate for this would be 0.25 GPM per square feet. And below the transformer, there is non-absorbing grounding surface area. That particular location also shall be provided with water spray nozzle. However, that location should be having design density of 0.15 GPM per square feet. The water supply shall be capable of supplying both the design flow rate and host stream allowance of 250 GPM for a minimum of 1 hour duration. So the transformer, for example, if you look at this particular figure, this transformer will be sitting on some concrete or concrete pads beneath the transformer. So that area shall also be covered with the design density of 0.15 GPM per square feet, and no piping across the top level or top or across face of the cabinet or access. This is also a consideration. And the spray nozzle shall be provided in such a way that it should not obstruct any of the energized parts of the transformer. So electrical clearances will also be available in NFPA 15. How much clearance should be required if we want to install the piping near the transformers, and all those things will be discussed in our future classes when we discuss about the complete design concept of the transformers. So no direct impingement on energized bushings. or lighting surge protectors. These are some of the few considerations at this point of time we will remember. Flammable vapor mitigation. This is an advanced topic. However, I will throw some light on this. For example, you have a power plant, and the power plant, obviously sometimes there will be some gas or vapor leaks, and in order to prevent the catastrophic fires in these scenarios, we need to use water spray systems as well. So fixed water spray systems are designed to control flammable vapors by mixing air with the water droplets in spray cone, which helps dilute the vapor and reduce its flammability. So current standards like API RP 2030, API RP 2030, and NFPA 15 guide can be used in order to provide the water spray system. However, we don't have much information related to this. Thank you for all your support. Please subscribe for more and keep supporting the channel. Fire protection videos, path to success with online learning. Thank you once again. Bye. Thanks for watching. If you have any comments, let me know through comment section. Thank you once again.